I'm sure you're looking at this page and you're curious exactly what it is you're supposed to do with it. Well, let me show you. You are to pick anything that you want that you can time, any sort of a personal rate. These are some options that I came up with. If you can think of anything else that you can time per minute, you are welcome to use that, really anything. I decided to time myself running laps up and down the steps. So up and down 1, up and down 2, up and down 3. And let me show you what my paper looks like. Here we go. It took me 6.5 minutes to run 1 lap. Notice the directions say values from 0 to 10 minutes. That should be a 0. The first time I did this, I went 1 to 11, and then I read the directions and realized, oh, 0 to 10. So I redid it. Make sure you do it right the first time so you don't have to redo it like I did. Anyhow, so I did exactly 6.5 trips in 1 minute. Based on that rate right there, I extrapolated the rest. Now, to be perfectly honest, this would not be a reasonable unit rate. In 10 minutes, there's no way I would do 78 laps because after 6.5 laps, I was pretty tired. In reality, I would have done more like 7, I don't know, maybe 8 or 9 laps in 10 minutes because I didn't have much left in me. But we are assuming for this assignment that it is a constant rate. So we will assume that for 10 minutes, I ran at a constant rate of 6.5 trips in a minute and ultimately did 78 trips. Anyhow, so with that, all I did was 1 minute was 6.5, then 2 minutes was 13, 3 minutes was 19.5. I converted this to a decimal just because it's easier to compute. And so the rest of them are decimals. Either way, it's the same amount. So, 4 minutes, 5 minutes, 6 minutes, on up to 10 minutes. Over here, I did what you need to do first. Before you can do any graphing, the very first thing you do is write the labels. The reason you write the labels first is because then you can look at your numbers and decide how you need to number here. If you are doing time and you go up to 20 minutes, then obviously counting by ones wouldn't be right. So that's why you do the labels first. This is the x-axis, so the x values are time. This is the y-axis, so all of these will be the laps. Note also that I qualified the time as minutes. There are all sorts of different measurements of time. And so day, year, month, it's important to give meaning to these numbers. So I added the term minutes. This will be the same on yours. No matter what you choose to chart, to time yourself on, no matter what, this will be the time down the bottom. And just number it 1 to 10. Or I did 11, but there's not 11 minutes on here. And then this will be whatever it is that you're timing yourself. Given these values right here, I can go ahead and chart it, or plot my points. Now, I wanted to make sure that I could get at least 2 values in my chart besides the 0. And so that's why I had to think about that before I did my numbering. It turns out that I could easily fit in 2 just by numbering by 1. So that's what I've chosen to do. So 0, 0 will be my origin. X is 1, Y is 6.5. 1, here's 6, here's 6.5. 2 is 13, so 2 minutes. I go up to 13, and I don't have room for the next one. So now I will get my ruler, put my little pencil here to hold my ruler in place. This has always been the best way I can think of to get the ruler measured. I put my pencil on the dot, put the ruler up against it, and then I move this end until it's just right. Otherwise, you do this, and then you move this one, and that one kind of goes, and then you move that, and then you move this. So that's why I do it this way. Done it this way since I was in, I don't know, junior high school. This is what my graph would look like, assuming this were a constant rate. We're pretending that it is. We're pretending that I'm in such good shape that I could do 78 trips up and down in 10 minutes. Write an algebraic expression to describe your graph. Well, we'll always start with y equals. Because this is the dependent value. The time, well, we just kind of, that was the given. We had to actually figure out what this would be. So that's why y equals. For every minute, for every 1 minute, I ran 6.5 laps. Y equals 6.5 times x. Whatever this value is, you multiply it by 6.5 and you get that. So that is the expression for my graph. If we were to talk about the slope of the line, if we put that into fraction form, would be 6 1/2, which would be 13 halves. The slope would be 13 over 2. Let's see if that's right. We go 1, 2, 3, 4, 5, 6.5 over 1. 6.5 over 1. Double that. Get 13 over 2. You see? Got my slope. See how that works? That's kind of neat. And since there's no constant afterward, we started at 0, 0. Just like when you don't have the y-intercept, it's 0, 0. All right, assuming the constant rate, answer the following questions about your graph. How many, I don't know, I guess laps, I was thinking trips, but laps, would you have after 9 minutes? 65 and a half. 65 and a half. After 4.5 minutes, after 1 hour. All right, 4.5 minutes times 6.5. Let me get my little Pippa. So 4.5 minutes times 6.5 laps per minute. Almost forgot. In 4.5 minutes, I could do 29.25 laps. 29 and a fourth lap. In 1 hour, well, 1 hour is how many minutes? 60. I'll multiply 60 minutes times 6.5. 6.5 times 60. 0. Okay. Wow. 390 laps in an hour. That is not happening. How much time would need to pass for your answer to reach 40? 40 laps. If my formula is y equals 6.5x, and I want the number of laps to be 40, then I will solve the equation and I will substitute y with 40 because y is the number of laps. So 40 equals 6.5 laps x. This is an equation, and I need to get the x all by itself. Right now I'm multiplying it times 6.5, so to get rid of that quotient, I'm going to divide both sides by 6.5. Now I've got 40 divided by 6.5. That has a decimal in it, so I'll move it over. And I'll move that over. So I end up with 65 into 400. This has turned into quite a problem because, 39 is so close to 40, so it's just a tiny bit past that. I'm going to end up rounding it to the nearest hundredth. I'm just going to go ahead and plan on that. Well, no, the nearest hundredth. Okay. 65 goes into 0. 5 goes into 400. I don't know. I'm going to say 5 times. Let's try. Up 6 times. Can go in one more time. 6. 6 times 6. 6 times 5 is 30. 36, 37, 38, 39. So 390. Can you erase that? Oh my. 400 minus 390 is 10. Bring down the 0. 65 goes into 100. 1 up. I already know that this is 35. Bring down the 0. 5 times. 325. 250. 65 goes into, you know what? I got an idea. 65 goes into 250 3 times. I tried 4, that didn't work. 3 times 5 is 15. 3 times 6 is 18, 19, 20. When I subtract, I get 45. All right, so I'm done because I'm rounding this to the nearest hundredth. 3 rounds down. So I would do, well, this was a complicated one. I would do 6 and 15 hundredths. It would take me 6 and 15 hundredths of a minute to go up and down 40 times. So 6 minutes and 15 hundredths of another minute. Just a little bit more than 6 minutes. Now compare your graph with your partners. Describe how they are similar or they are different. It'd be interesting if you did it with someone else in your family. You don't have to. I did mine with Rachel. Hers was 7 laps in a minute, which was just half more. So if you look at our graphs, they're almost identical. Just barely different. I did 13 laps in 2 minutes, and she did 14 laps in 2 minutes. And we put those together, you can barely see the difference in the slope, but they're almost identical. Her slope would be 1, 2, 3, 4, 5, 6, 7 over 1. Her slope would be 7 over 1. Her slope is 7, whereas my slope is 6.5. In fact, look at her equation. Y equals 7x. That's the slope, 7. There is no constant because the origin is where it meets the y-axis. So, now, back to your page. Pick anything you want to do, anything that you want to do that's fun. Maybe there's something that you can get away with doing that you're not usually allowed to do, but your parent will make an exception for this assignment. Pick something cool. Anyhow, when you get down to number 3, it's always going to be y equals, and finish that. And then, of course, you don't have to do this. You can if you want, but that is not part of the assignment. I think this is fun, so I hope you find something that you enjoy doing.